Hello students, I am Robot Demishu. Today I will tell you the theory on the basic concepts of matter, energy and force in physics and scientific methods in physics. In physics, matter, energy, and force are fundamental concepts that form the basis for understanding the behavior of the physical world. Let's explore each of these concepts. Energy. Definition: energy is the capacity to do work or cause a change. It comes in various forms, and the law of conservation of energy states that energy cannot be created or destroyed, only transferred or converted from one form to another. Forms of energy. There are several forms of energy, including kinetic energy, energy of motion; potential energy, energy stored due to position or condition; thermal, heat, energy, related to the temperature of an object; chemical energy, stored in the bonds between atoms and molecules; electromagnetic energy, including light and other forms of radiation. Force. Definition: force is a push or pull that can change the state of motion of an object. It is characterized by its magnitude and direction. Newton's laws of motion. Sir Isaac Newton formulated 3 laws of motion that describe the relationship between a body and the forces acting on it. First law, law of inertia: an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted on by an external force. Second law, the force acting on an object is equal to the mass of that object multiplied by its acceleration, F equals ma. Third law, for every action, there is an equal and opposite reaction. These concepts are foundational to the study of physics and provide a framework for understanding the behavior of matter and energy in the universe. The interplay of these elements is fundamental to explaining the diverse phenomena observed in the natural world. In physics, matter is the term used to describe anything that has mass and occupies space. It is one of the fundamental concepts in the study of the physical world. Matter. Here are some basic concepts related to matter in physics. 1. Mass. Mass is a measure of the amount of matter in an object. It is a scalar quantity and is usually measured in kilograms, kilogram, in the International System of Units, c. 2. Volume. Volume is the amount of space that matter occupies. It is also a scalar quantity and is typically measured in cubic meters, m cubed, in the SI system. 3. Density. Density is the mass per unit volume of a substance. It is expressed mathematically as density, ρ, equals mass, m, volume, v. The SI unit for density is kilograms per cubic meter, kilogram per cubic meter. 4. States of matter. Matter can exist in different states: solid, liquid, and gas. The state of matter depends on the arrangement and motion of its particles. In a solid, particles are closely packed and vibrate in fixed positions. In a liquid, particles are still close together but can move past one another. In a gas, particles are more spread out and move freely. 5. Elements and compounds. Matter is composed of elements, which are substances that cannot be broken down into simpler substances by chemical reactions. Elements consist of atoms of the same type. Compounds, on the other hand, are substances composed of 2 or more different elements chemically combined in fixed proportions. 6. Atoms. Atoms are the basic building blocks of matter. They are the smallest units of an element that retain the chemical properties of that element. Atoms consist of a nucleus containing protons and neutrons, surrounded by electrons. 7. Molecules. molecules are formed when two or more atoms chemically combine. They can be composed of atoms of the same element, as in diatomic molecules like O2 or N2, or different elements, as in water, H2O. 8. Mixtures. Mixtures are combinations of different substances in which each substance retains its own chemical properties. Mixtures can be homogeneous, uniform composition, or heterogeneous, non-uniform composition. 9. Chemical reactions. Chemical reactions involve the breaking and forming of chemical bonds between atoms, resulting in the creation of new substances. The total mass of the reactants is equal to the total mass of the products, according to the law of conservation of mass. 10. Energy and matter. According to Einstein's famous equation, E equals mc squared, matter can be converted into energy, and vice versa. This principle is fundamental to understanding nuclear reactions and the relationship between mass and energy. Understanding these basic concepts provides a foundation for exploring more advanced topics in physics, chemistry, and other scientific disciplines. Scientific methods in physics. Scientific methods in physics, as in other scientific disciplines, involve a systematic approach to investigating and understanding natural phenomena. The scientific method is a general framework that scientists use to formulate and test hypotheses, gather and analyze data, and draw conclusions. Here's a brief overview of how the scientific method is applied in physics. Observation. The process begins with observations of the physical world. Scientists carefully observe and identify interesting phenomena or patterns that need explanation. Question. Problem formulation. Based on observations, scientists formulate questions or problems that need to be addressed. These questions often lead to the development of hypotheses. Hypothesis. A hypothesis is a tentative explanation for the observed phenomena. It is a statement that can be tested through experimentation and observation. A good hypothesis is specific, testable, and falsifiable. Experimentation and data collection. Scientists design experiments to test the hypothesis. Experiments involve controlled conditions, variables, and measurements. Data is collected through systematic observations and measurements. Analysis. Collected data is analyzed to identify patterns, trends, or relationships. Statistical methods may be used to evaluate the significance of the results. Conclusion. Based on the analysis, scientists draw conclusions regarding the hypothesis. If the data supports the hypothesis, it may be accepted. If not, the hypothesis may be revised or rejected. Peer review. The results and conclusions are often subjected to peer review, where other experts in the field evaluate the experimental design, data analysis, and conclusions. This process helps ensure the validity and reliability of the research. Publication. Successful studies are typically published in scientific journals, contributing to the collective knowledge of the scientific community. Further testing and verification. Scientific knowledge is dynamic and subject to change. Other researchers may conduct similar experiments to verify or challenge the findings. Reproducibility is a key aspect of the scientific method. Theory development. If a hypothesis consistently withstands testing and is supported by a substantial body of evidence, it may be elevated to the status of a scientific theory. A scientific theory is a well-substantiated explanation of some aspect of the natural world that is based on empirical evidence. In physics, these steps are followed rigorously to explore, explain, and understand the fundamental principles governing the behavior of matter and energy in the universe. The scientific method is a powerful tool that allows physicists to build a progressively more accurate and comprehensive understanding of the physical world. The basic concepts of measurement in physics. Measurement is a fundamental aspect of physics, providing a quantitative basis for describing and understanding physical phenomena. Here are some basic concepts related to measurement in physics. Fundamental quantities. Physics deals with fundamental quantities such as length, mass, time, electric charge, temperature, and so on. These quantities are considered basic and cannot be defined in terms of other quantities. Units. Units are standardized measures used to express quantities. The International System of Units, SI, is the globally accepted system for measurement in physics. For example, the unit of length is the meter, m, the unit of mass is the kilogram, kilogram, and the unit of time is the second, s. Precision and accuracy. Precision refers to the degree of exactness of a measurement, and accuracy refers to how close a measurement is to the true or accepted value. A measurement can be precise but not accurate, accurate but not precise, both, or neither. Error and uncertainty. Every measurement has some degree of uncertainty due to limitations in the measuring instruments or experimental conditions. Error is the difference between a measured value and the true value, while uncertainty reflects the range within which the true value is likely to lie. Significant figures. Significant figures are the digits in a measurement that carry meaningful information. Rules for determining the number of significant figures help express the precision of a measurement. Measurement instruments. Physics utilizes various instruments to measure different quantities. Examples include rulers and calipers for length, balances for mass, clocks for time, thermometers for temperature, and voltmeters for electric potential. Calibration. Calibration ensures that a measuring instrument provides accurate and reliable measurements. It involves comparing the instrument's readings to known standards and making adjustments if necessary. Derived quantities. Many physical quantities are derived from fundamental ones. For instance, velocity is derived from the fundamental quantities of length and time, and acceleration is derived from velocity and time. Measurement systems. Different measurement systems exist, but the SI system is the most widely used in physics. Conversion between units within the same system involves multiplying or dividing by a conversion factor. Understanding and applying these measurement concepts is essential for conducting accurate and meaningful experiments, analyzing data, and advancing scientific knowledge in physics. For the rest parts of measurements, Teacher M will show you. Thank you for watching. See you soon.
Hello students. Today we will see additional part about today's lesson as robot. Let me start to teach you most of the theory part, and let me show you some parts about the instruments that helps us measure quantities. For example, here we have micrometer, meter ruler, protractor, Wiener couplers, stopwatch. You see this stopwatch. We use this stopwatch to measure time. Ammeter to measure current. Voltmeter, thermometer to measure temperature. Voltmeter, with this voltmeter we can measure DC volt or AC volt. We will see in the future the other galvanometer, top pan balance. This top pan balance is instrument helps to measure mass. The cathode ray oscilloscope. Yes, this is another stuff to measure the frequency, but here are some of the instruments, and we have other types of instruments. I will show you in the future. The other part about prefix. It's very important. These prefix are multipliers. For example, let me open my. Okay, good. Let me show you here. It's very important to okay. Here are some of the prefix. Let's start from the middle. DC. Look, DC. Its symbol D and its multiplier 0.1 or 10 to the power of minus 1. Kilo, its symbol K, its multiplier 1000, its scientific notation here, scientific notation. Okay, my color is not good. Here its scientific notation 10 to the power of 3 kilometer. Yeah, like this. If we see centi, for example, centi C, its value 0.01, and its scientific notation written in the form of 10 to the power of minus 2 and centimeter. We use this prefix when we multiply, or if we see some prefix, we can convert one to another. For example, let's say we have a mass is equal to 1 kilogram. Kilo, look at the prefix kilo. Let me change my pen. No, sorry. Here, kilo. We have kilo 1000. So to convert 1 kilogram to gram, we use 1 times kilo. How much? 10 to the power of 3 according to its scientific notation, times gram is equal to 1000 gram. In this way, we can convert one to another. If we see kilometer, the length, the distance, let's say distance is equal to 1 kilometer. Then we can write this one as 1 times 10. Kilo means 10 to the power of 3 times meter, which is equal to 1000 meter, because the prefix kilo, its value here is 10 to the power of 3. And this way we will see in the future. But this is an introduction, don't worry. You will understand it when we do some exercise. Thank you. Bye bye.